Welcome to this special edition of Frequency Matters. I'm Gary Lerude from Microwave Journal, and I'm here with Bryan Goldstein, who's the General Manager of the Aerospace and Defense Business Unit at Analog Devices. Bryan, thanks for joining us.
Well, thank you, Gary.
Let's talk a little bit about GaN. I was impressed at the International Microwave Symposium, which we just completed a few weeks ago. The fact that GaN seems to be crossing the threshold into the commercial markets, principally the wireless infrastructure side. But of course, it's been playing for years, and the motivation for developing it came out of the defense market. And I think you were an early adopter in terms of using GaN. Can you talk a little bit more about how you're using the technology and what kind of applications you're inserting it into?
Absolutely. We're very, very heavily involved in GaN at both the semiconductor level and at the module level. Power densities that can now be achieved are a real game changer in the industry. The volume of devices that are used in phased array application and the high number of devices that can be combined to create very high power levels to replace TWTs and magnetrons have gotten the volume of GaN up to a point that it's very, very interesting, and ultimately the price will get to a point where the commercial markets are able to adopt it more readily as well. Working in both GaN on silicon carbide, where we can get the optimum performance, and GaN on silicon, where we can get the cost down and do some higher levels of integration, are both areas of interest for us. Imagine, if you will, where you could combine your high-speed converter technologies with your RF microwave, with your high-power amplifiers, and all the biasing circuitry that goes around the GaN and the linearization that goes around the GaN, all on a single piece of silicon. You could start to imagine phased array radars. You could imagine EW systems all on a single wafer of silicon. So this is very interesting to DARPA. It's very interesting to Analog Devices, who is going to help them get there. Currently in GaN, we're filling out our GaN component portfolio at the semiconductor level, and in parallel we have a number of interesting products that we're doing at the module level. Just this year we've developed a 2 to 18 gigahertz 100-watt power amplifier module, as well as an 8 kilowatt X-band power amplifier module. The 2 to 18, of course, being for EW and test equipment application, and the X-band being for either weather or military tracking weather applications. As far as our roadmap, we will continue to fill the portfolio and go to wider bandwidths, higher power levels, and higher frequencies, and ultimately into Ka band and W band and beyond.
Right. It's amazing what the technology has done. One of my early assignments in my career was doing a 6 to 18 gigahertz 1-watt power amplifier, and we thought it couldn't be done. And now you're talking about 100 watts, 2 to 18.
It's absolutely, the market and the technology has moved very, very quickly over the years. Where have the years gone?
Yeah.